Welcome to Engineering Research Insights. I'm Emmy Think, and I couldn't be more excited to have you join me for today's episode. We're tackling an essential and dynamic topic that lies at the very heart of innovation: the types of research in engineering, with a spotlight on mechanical engineering. Research is the spark that fuels progress. It's how we tackle challenges, push technological boundaries, and shape the future. Whether you're an aspiring engineer ready to dive into the field, a seasoned pro looking to stay ahead of the curve, or just someone curious about how ideas transform into groundbreaking solutions, this episode is for you. So buckle up, because we're about to break down the core types of research: basic research, applied research, and pure research, and uncover the fascinating characteristics that make research a cornerstone of advancement. Let's get started. For our first segment, what is research in engineering? Before we jump into the specific types, let's take a step back and ask, what is research in engineering? Engineering research is a systematic process that combines theory, experimentation, and practical application to solve real-world problems. In mechanical engineering, it could range from developing lightweight materials for aerospace applications to optimizing thermal systems for energy efficiency. But not all research is the same. There are different approaches based on goals and outcomes. Let's start with the foundation, which is the basic research. Basic research, sometimes called pure research, is driven by curiosity and the desire to expand knowledge. It focuses on understanding fundamental principles and phenomena without a direct application in mind. For example, in mechanical engineering, basic research might involve studying the molecular structure of metals to understand why some are more heat resistant than others. The goal is not to create a product immediately, but to build a knowledge base that can be applied in the future. One key characteristic of basic research is that it often lays the groundwork for applied innovations. Think of it as the engine that powers the innovation train. It provides the theoretical understanding upon which practical solutions are built. Now let's shift gears to applied research, which is where engineering shines. Applied research is all about solving specific problems or addressing practical challenges. It takes the knowledge from basic research and uses it to develop tangible solutions. For instance, an engineer conducting applied research might use insights from basic research about heat-resistant metals to design a turbine blade that can withstand extreme temperatures in jet engines. Applied research bridges the gap between theory and real-world application. In mechanical engineering, some exciting examples include developing more efficient HVAC systems to reduce energy consumption, designing robotic systems for precision in manufacturing, enhancing the performance of renewable energy systems like wind turbines and solar panels. This type of research directly impacts industries, economies, and even our daily lives. Now let's move to pure research. You might hear pure research used interchangeably with basic research, but there's a subtle distinction. Pure research is often curiosity-driven, like basic research, but it's typically broader and doesn't necessarily target a specific discipline. In mechanical engineering, pure research could involve exploring how fluid dynamics behave in microgravity, research that might not have immediate applications but could one day be crucial for space exploration. The key takeaway here is that pure research emphasizes exploring the unknown, which often leads to unexpected discoveries that redefine entire fields. Regardless of the type, all engineering research shares common characteristics that ensure it is systematic, rigorous, and impactful. So let's break these down. 1. Problem-solving focus. Engineering research is typically driven by specific challenges, such as designing more fuel-efficient engines or developing lightweight, durable materials. 2. Interdisciplinary approach. Collaboration with other fields like materials science, robotics, and computer science enhances the scope and effectiveness of engineering research. 3. Iterative and rigorous research involves cycles of designing, testing, analyzing, and refining until the desired outcome is achieved. 4. Quantitative and analytical. Engineers rely on mathematical models, simulations, and data analysis to validate their findings and predict performance. 5. Application-oriented. The ultimate goal of engineering research is to develop practical, real-world solutions that improve efficiency, sustainability, and quality of life. Understanding these characteristics not only highlights the value of research, but also the discipline and creativity it demands. After everything was discussed, let's understand why the research matters in mechanical engineering. Well, to answer that simply, mechanical engineering research is crucial because it drives innovation and addresses global challenges. For example, robotics research is transforming industries by enabling automation and precision. Renewable energy research is paving the way for a more sustainable future. Research in additive manufacturing or 3D printing is revolutionizing on how we design and produce everything, from medical implants to car parts. Without research, progress would grind to a halt. So it's the foundation of innovation and the catalyst for change. And to sum it all up, research in mechanical engineering takes many forms: basic, applied, and pure, and each type plays a critical role in shaping our world. Whether it's understanding fundamental principles, solving specific problems, or exploring uncharted territories, research drives technological progress and improves our quality of life. So, if you're an aspiring engineer or researcher, I encourage you to stay curious, ask questions, and never stop exploring. After all, research isn't just about finding answers, it's about unlocking new possibilities. Thank you for tuning in to Engineering Research Insights. If you enjoyed this episode, don't forget to subscribe. I'm Think, and I'll catch you next time for another deep dive into the fascinating world of engineering.